Hello everyone. Welcome to another lesson of Edexcel IT A2 paper. So in this we will cover topic 12.3 Big Data. So this is the last section of topic 12. As usual here I have listed the syllabus and specification for Big Data and I intend to cover all this content in this video. Okay, big data is defined as a complex and high volume set of information comprising structured, unstructured, and semi structured data sets, which is challenging to manage using traditional data processing tools. It requires additional infrastructure to govern, analyze, and convert into insights. Another definition is that big data is a quantity of data that is enormous in volume and is constantly expanding rapidly. No typical data management system can effectively store or analyze this data because of its magnitude and complexity. So, big data is a collection of organized, semi structured, and unstructured information gathered by businesses that can be mined for information and utilized in advanced applications of analytics like predictive modeling and machine learning. And big data are collected passively from digital interactions. They come with great variety. So, together with the technologies that support big data analytics purposes, systems that process and store big data have become a regular part of business data management infrastructures. Like knowing how big data functions and how to use it requires a thorough understanding of its characteristics. So, these fundamental characteristics of big data are called the five V's of big data. So the first V is volume. The volume of your data is how much of data is there, and it could be measured in gigabytes, zettabytes, and yottabytes, and uh, in like bigger scale data sizes, and also industry trends predict a significant increase in data volume over the next few years. Earlier there were issues with storing and processing this enormous volume of data, but nowadays data gathered from all these sources is organized using distributed systems like Hadoop. Understanding the usefulness of the data requires knowledge of its magnitude. Additionally, one may use the volume to identify if a data set is big data or not. The second V is velocity. Velocity describes how quickly data is processed. Any significant data operation has to operate at a high rate. The linkage of incoming data sets, activity burst, and the pace of change make up this phenomenon. Sensors, social media platforms, and application logs all continuously generate enormous volumes of data, so there's no use in spending time or effort on it if the data flow is not constant. The third V is variety. The many types of big data are referred to as variety as it impacts performance. It is one of the main problems the big data sector is now dealing with. It's crucial to organize your data so that you can manage its diversity effectively. Variety is the wide range of information you collect from numerous sources. The fourth V is veracity. Uh, Veracity is the correctness of your data. The accuracy of your findings can be severely harmed by poor veracity, making it one of the most crucial big data qualities. So it specifies the level of data reliability. It is vital to remove the information that is not essential and use the remaining data for processing, because most of the data you encounter is unstructured. Fifth and the last V is value. Value is the advantage that the data provides to your company. Does it reflect the objectives of your company? Does it aid in the growth of your company? It's one of the most crucial fundamentals of big data. I mean, data scientists first transform unprocessed data into knowledge. The best data from this data collection is then extracted once it has been cleaned. So, on this data set, analysis and pattern recognition are performed. The results of the of the method used to determine the value of the data. Okay. The information contained in big data repositories can be classified into six types. Let's look at what those six types are. First type is the structured data. So this data type is well defined and organized, as the name suggests as well. It has a clear structure that either a computer or a person might understand. So it's well structured information that can be quickly and easily stored in a database and assessed during straightforward methods using straightforward methods. And since you know the data format you will use in advance, this sort of data is simplest to manage. Structured data is, for instance, the information in a business keeps in its databases, such as tables and spreadsheets. The second type is semi-structured data. Semi-structured data, as the like the terms implies, combines structured and unstructured data. It is information that hasn't been categorized into a particular database, but still has crucial tags that distinguish different pieces within the same semi-structured data. For instance, may be found in relational database management system table definitions. Although not entirely organized, this type of data has some organization. At first glance, this can appear to be unstructured and conventional data model frames. As an illustration, no SQL text may be processed using keywords. CSV files are regarded as semi-structured data as well. Third type is unstructured data. Unstructured data is data that has no recognized structure. Its size uh, significantly, more extensive than structured data. And unstructured data refers to any collection of data that is not organized or clearly defined. So, this data type is chaotic and challenging to handle, comprehend, and evaluate. It doesn't have a set of structure and can change at different times. You will encounter the majority of big data in this category. Unstructured data includes social media comments, tweets, shares, posts, the YouTube videos users view, and then WhatsApp text messages they send. So those are unstructured data. And fourth type is geospatial data. Geospatial data is information on things, occasions, or other features located on or close to the Earth's surface. Geospatial data often combines temporal information with location information and attribute information, the traits of the item, event, or phenomenon in question. Uh, the site reported may be static, such as the location of a piece of equipment, an earthquake occurrence, or poor children, or and for instance, a moving car, the spread of an infectious illness. So those are the examples. The fifth type is machine or operational logging data. Machine data is information produced by a computer process or application activity without the involvement of a human being. Humans seldom alter machines' data, although it may be gathered and studied. So this implies that manually input data by an end user is not identified as machine generated data. These data increasingly being created by people accidentally or by machines, and they have an impact on all industries that employ computers in their everyday operations. Examples of machine data include call detail records and application log files. And the last type is open source data. Open source database uh, Open source databases house crucial data and software within the organization's authority. Users of an open source database can build a system to suit their own demands and professional requirements. It is free and open to share it. It may accommodate any user choice by changing the source code. Right. So, why big data is so important? Because big data can improve business operations, offer more personalized service to customers, improve marketing campaigns, and I mean, in general, contribute to more efficient decision making. When a business knows how to use its data, it gains a competitive advantage over those that don't. So, which makes it easier to grow and to increase the market share. So, industry can use data to its advantage in many ways, like product development. You can build predictive models and anticipate customers' demands, thereby reducing risk when releasing new products. Customer experience wise, when you compile data from consumers in many different contact channels, you can make personalized offers and manage problems proactively. And it also driven innovation. uh, Knowing the data and analyzing trends helps improve financial planning and decision making, efficiency in operations. You can analyze and assess production through customer feedback and anticipate demands. And also for machine learning, you can use data to teach computers instead of programming them, and also detect and reduce fraud. You can identify patterns that help find fraud and suspicious activity, and also important for predictive maintenance. Uh, you can foresee potential problems before they occur, so it helps to you to plan ahead. Right. So here's a diagram of a big data infrastructure. This is out of scope of your syllabus, but you can understand like how complex a big data infrastructure is compared to a simple software application saving data to a database. So you can imagine the difference. Like in a simple web application, we might have a single data store, but here in the big data infrastructure, it's really complex. No need to remember this part because this is out of your syllabus. Okay, the three key components of big data infrastructure is collection, storage, and transmission. Uh, Collection, storage, and transmission of data is an area where changes may happen due to both domestic and international politics and new trade agreements. You should know about types of laws, regulations, rather than specific detail that may be contained in them. For an example, GDPR require personal data of EU personnel to be stored within EU's geographic boundaries. So, if your big data solution is to collect personal data, the solution must store them accordingly, or remove sensitive information that comes under regulations before transmitting and storing out of the region. Big data collection is the process of gathering data from various sources, ensuring its accuracy, and organizing it for analysis. Depending on the application, data may be collected in batch or real-time processes. So these data collection processes are called ETL processes or pipelines. ETL stands for E for extract, T for transform, and L for load. So data isn't only growing in size but also variation and format. For an example, structured, unstructured, and semi-structured. Flexible data integration processors or pipelines ensure smooth and error-free data flow from business tools to the data warehouse or the data lake. We will learn about them in a future lesson. Big data storage solutions accommodate the massive volume and variety of data. So these solutions include traditional relational databases, NoSQL databases, data lakes, and distributed file systems like Hadoop. Uh, we will elaborate about Hadoop and in a while. As mentioned above, data is complex. It can be structured like relational databases with proper tables and keys, unstructured like images, audio, video, and text, and semi-structured like emails, graphs, code, and XML files. So today, an organization's data infrastructure could be compatible with a multitude of databases and data sources, so which can be achieved using data connectors that allow real-time data transfer across the pipeline. Uh, Big data transmission solutions and protocols accommodate transmission of large volumes of data at a very high rate, such as in streaming data as well as transmission of big files as batch jobs. So, an important aspect to learn is that there were limitations found with the TCP protocol when used for big data transmission. Therefore, new protocols were developed and is being developed continuously to accommodate more volume and speed of big data. So, transmission either to replace TCP protocol or to enhance it. Uh, So, increasing use of wireless and Wi-Fi and associated problems is another area of concern for big data transmission. The problems range from non-constant bandwidth to other users transmitting on same channel to interference. So, on the positive side, advances in fiber optics, submarine cable network, and coverage, and advances in data compression has helped toward big data solutions. So we will next dive a bit deep into each of these. Right. So the data collection methods. Big data is collected through various methods and sources in the present digital age. We will discuss some common methods of collecting big data. So gathering data from online marketing campaigns and analyzing customer behavior and preferences is the first method. Secondly, Internet of Things IoT devices such as sensors and connected devices generate vast amount of data. So these devices collect information about temperature, pressure, location, and movement, and more, providing like real-time data streams. Third is gameplay, gathering data from video games and analyzing player behavior and interactions. Fourth is social media platforms. Social media usage has exploded around the world, and hence our daily behavior, thinking, and our likes and dislikes, etc., can be pretty much analyzed using social media data. Social media platforms generate enormous amount of data through data interactions, like post, comments, likes, and shares. So companies can assess and analyze this data to understand customer sentiments, trends, and preferences. Other one is web and online data is the next method. Web scraping and crawling techniques are used to extract data from websites, online forums, and other online sources. So this data can include user reviews, product information, and news articles. Number six is transaction records. Transactions, e-commerce purchases, and banking activities generate large volumes of data. So this information is valuable for businesses to understand consumer behavior and financial trends. Number seven is machine and system logs. Machines and software systems generate logs containing valuable operational data. Analyzing these logs can help detect anomalies, track system performance, and troubleshoot issues. Next method is mobile devices. Mobile apps and devices collect data such as user interactions, location information, app usage patterns, and even users' health data such as heartbeat, number of steps they walk, what exercise routines they had. So, this data is valuable for understanding user behavior and preferences. Ninth is biometric data. Biometric sensors and devices capture data such as fingerprint, facial features, and heart rate. So, this data is used in various applications, including security and healthcare. Last one, sorry, number 10 is satellite imagery. Okay, I can see there's a error in showing the numbers. Please disregard the number shown on the screen. Satellite imagery. Satellite imagery provides valuable geospatial data used for applications like weather forecasting, agriculture, urban planning, and environmental monitoring. Next method is loyalty programs and cards. Collecting data from loyalty programs and customer cards to understand purchasing patterns and preferences is the final collection method I have listed here. Uh, then we also have genomic data. DNA sequencing generates massive amount of genomic data, which is used in fields like personalized medicine and genetic research. Okay, what is Hadoop? Hadoop is an open source distributed processing framework that manages data processing and storage. Hadoop applications uses the Hadoop distributed file system, or HDFS in short, as the primary data storage system. It's an open source distributed processing framework for handling data processing, managing pools of big data, and storing and supporting related big data analysis applications. Uh, Here are some important features of HDFS. Uh, Remember, I mentioned HDFS is the Hadoop Distributed File System, shortened as HDFS. Right? Okay, so let's see the features. Uh, Data replication ensures that the data is always available and prevents data loss. For an example, when a node crashes or there's a hardware failure, replicated data can be pulled from elsewhere within a cluster, so processing continues while data is being recovered. Fault tolerance and reliability. HDFS ability to replicate file blocks and store them across nodes in a larger cluster ensures fault tolerance and reliability and high availability. Because of replication across nodes, data is available even if the name node or data node fails. Scalability. HDFS stores data on various nodes in the cluster, so as requirements increase, a cluster can scale to hundreds of nodes. So high throughput. Because HDFS stores data in a distributed manner, the data can be processed in parallel on a cluster of nodes. So this plus data locality cuts the processing time and enables high throughput. Data locality. With HDFS, computation happens on the data nodes where the data resides, rather than having the data move to where the computational unit is. So minimizing the distance between the data and the computing processes. Process decrease the network congestion and boost the system's overall throughput. Snapshots. HDFS supports snapshots which capture point in time copies of the file system and protect critical data. So, in addition to HDFS, there are many other data storage technologies used to store big data. There are differences of these technologies when it comes to what type of data can be saved and what operations are allowed. For an example, are we storing structure or unstructured data? Are there going to be many writes or retrievals? Are we looking at processing data and storing the processed data for future use? Like based on the need, we need to architecture our big data solution to use one or more of these technologies to bring the best out of our solution. These technologies are data warehouse, data lake, NoSQL databases, columnar databases, document stores, in-memory databases. In big data, there's no one fits all solution. We will explore more into each of these now. Let's now look at data warehouse and data lake technologies in detail. They look similar from the outset, but they are actually not. The common bit is both are storage technologies. A data warehouse is a centralized repository that stores structured data like database tables, Excel sheets, and semi structured data like XML files and web pages for the purposes of reporting and analysis. Uh, the data flows in from a variety of sources such as point of sale systems, business applications, and relational databases. and it is usually cleaned and standardized before it hits the warehouse, because a data warehouse can store large amounts of information. It provides users with easy access to a wealth of historical data, which can be used for data mining, data visualization, and other forms of business intelligence reporting. A data lake, on the other hand, is a centralized repository that ingests and stores large volumes of data in its original form. The data can then be processed and used as a basis for a variety of analytic needs. Due to its open, scalable architecture, a data lake can accommodate all types of data from any source, from structured to semi structured to unstructured data such as images, audio files, tweets, so all without sacrificing the fidelity. The data files are typically stored in state zones, raw, cleansed, and curated so that different types of users may use the data in its various forms to meet their needs. Data lakes provide core data consistency across a variety of applications. Now let's briefly look at the other database technologies used in big data. First up is NoSQL database. NoSQL databases are purpose built for specific data models and stores data in flexible schemas that scale easily uh, for modern applications. NoSQL databases are widely recognized for their ease of development, functionality, and performance at scale. This page includes resources to help you better understand and NoSQL databases to get started. Most commonly used NoSQL databases include MongoDB. Next up is columnar database. A columnar database, also known as a column-oriented database, is a type of database management system that stores data in columns together on disk. So this enables faster queries for data and analytics, which generally involves filtering and aggregating table columns. The third is the document database. Some classify document database as a subset of NoSQL database as well. Document databases have the same document model format that developers use in their application code. They store data as JSON objects that are flexible, semi-structured, and hierarchical in nature. Amazon Document DB is an good example for this. Fourth is in-memory databases, while other non-relational databases stores data on disk or SSDs. In-memory data stores are designed to eliminate the need to access disk. They are ideal for applications that require microsecond response times or have larger spikes in traffic. You can use them in gaming and edtech applications for features like leaderboards, session stores, and real-time analytics. Amazon MemoryDB for Redis is a Redis compatible durable in memory database service that delivers microsecond read latency. Fifth database is graph databases. They are purpose built to make it easy to build and run applications that work with highly connected datasets. They use nodes to store data, entities, and edges to store relationships between entities. Typical use cases for a graph database include social networking, recommendation engines, fraud detection, and knowledge graphs. Amazon Neptune is a fully managed graph database service supporting both the property graph model and the resource description. Transmission of big data involves sending and receiving massive volumes of data between different systems or locations. The process must be efficient, reliable, and optimized to handle characteristics of big data, large volumes of data, and very frequently or continuous streaming transmission. So, as we learned earlier, big data comes in different types, shapes, and sizes.
Hence, transmission must be able to cope with these big data types. The most used transport protocol around the globe is TCP. TCP was originally designed in an era where big data did not exist. There was a need for protocol to support such high volume fast transmission. The more important aspect that era was to build a reliable transport protocol to work over networks that are less reliable and much slower than what we have today. So hence TCP was designed with verifications and retransmission features to make sure that data is never lost during transmission over unreliable networks. Therefore, its overheads found in the layers make transmission of high volume, high veracity big data very much inefficient. So, you must know the limitations of TCP and be aware of efforts to replace it. It's not needed to know technical details of any proposed replacement, but should be able to explain in general terms why they are an improvement on TCP. These limitations are: number one, high overhead. TCP has relatively high overhead due to its extensive error checking mechanisms, acknowledgement of received data, and flow control. So, this overhead can become a bottleneck when transmitting large volumes of data, leading to slower the overall data transfer rates. Number two is latency. TCP is based on the concept of acknowledgement and retransmission, which ensures reliable data delivery. However, this introduces latency as the sender must wait for an acknowledgement. So before ending the next packet. Uh, For big data transmission, this latency can become a bottleneck as well. So number three is inefficient bandwidth utilization. TCP's congestion control mechanisms are designed to ensure fair sharing of network bandwidth among multiple users and applications. But in high speed and high volume data transfer, these mechanisms can sometimes unnecessarily slow down data transmission. Number four is the inefficient for streaming. For streaming applications that require a continuous flow of data without process, TCP's congestion model and acknowledgement mechanisms can lead to interruptions and variable data rates. Number five is limited scalability. TCP is designed for point to point communication between two hosts. When dealing with big data, which often involves distributed systems and multiple nodes, TCP may not scale efficiently to handle the increased traffic and data volume. So, to overcome about TCP limitations, alternative protocols uh, and technologies are introduced. We now move on to section 12.3.3 and we look at the impact of storing big data. We specifically look at the impact into four areas. They are access to big data, transmission time of big data, security of big data, and processing time of big data. So let's dive deep into each of these areas, starting with access. Access the big data requires identifying the right data stores, understanding who has access to organizations' data, and knowing the right query language to use and utilizing the tools to view and understand the data. So, earlier in this lesson, we discussed in detail about different database technologies available to store big data. So, knowing the type of data and the technology that suits is important. Data access in big data refers to the ability to retrieve and utilize data stored in a database or other storage system. So it encompasses a range of activities including data retrieval, data management, data analysis, and protection. So query languages to access the big data range from SQL to NoSQL to HQL. HQL is Hive query language. So when choosing a big data solution, it's important to consider the needs of users across departments or levels of expertise. Some employees may only need to access to a graphical interface without any querying capability. Some more technical users might need access to build their own queries and reports. Second one, the transmission time. The use of correct media to match the volume, frequency, and veracity of big data has a huge impact on the big data transmission time. So organizations sometimes invest in upgrading their network infrastructure with new and faster networks, high bandwidth, and upgrade network devices, and as well to handle high speed and high capacity needed for the big data being transmitted. Further, the data centers also needs to be designed to handle increased data movements and high volumes of transfers. Data centers will have to deploy multi-location models with load balancing. Big data security. Okay. It can be termed as the tool and measures which are used to guard both data and analytics processes. The main purpose of big data security is to provide protection against attacks, thefts, and other malicious activities that could harm the valuable data. Big data security challenges are multi-phase for the companies that operate on the cloud. The challenging threat includes the theft of information stored online, ransomware, or DOS attacks that could crash a server. So these threats can cause serious financial repercussions such as losses, litigation costs, and fines or sanctions of an organization. Sensitivities around big data security and privacy are a hurdle that needs to be overcome as well. Encryption is one of the most common security tools. Encrypted data is hard to decode for hackers. Encrypted data is generally done for the incoming data as well as for outgoing data. If we look at the other big data security tools, then the best one is firewall. Firewalls are usually used to filter the traffic that enters and leaves the servers. Firewall creates strong filters that prevent attacks from malicious activities. Business intelligence tools, the BI tools, and analytics platform is another key to protect vital information of the organizations. BI tools used to create an access system that can reduce the possibility of an attack to a great extent. The processing time of big data can have a significant impact on various aspects of data analytics and operations. Encrypting data enhances security but introduces processing overhead. Striking the right balance between security and processing times involves evaluating the sensitivity of data, potential risk, and available processing resources. Accordingly, we can make informed decision on like what data we need to encrypt and what not to strike the correct balance. Encrypting and decrypting data can increase processing time, especially for large data sets. So this overhead might be acceptable for some use cases but could impact real time or near real time processing of big data. Furthermore, the encrypted data often requires decrypting it first, which can impact processing times. So, however, modern hardware and encryption techniques are optimized to minimize this impact. So, choosing the machine processing type also impacts on processing time. Employing different processing architectures such as real-time processing, batch processing, reverse ETL to match how soon data is needed after collecting them also can optimize processing time where the outcome is that information will be available close to when it is needed by users. Moving further down, the building blocks of a big data solution, we find data mining. Data mining is the process of sorting through large data sets to identify patterns and relationships that can help solve business problems through data analysis. So, data mining techniques and tools help enterprises to predict future trends and make more informed business decisions. Data mining is a key part of data analytics and one of the core disciplines in data science, which uses advanced analytics techniques to find useful information in datasets. The process of data mining relies on the effective implementation of data collection, warehousing, and processing. Data mining can be used to describe a target data set, predict outcomes, security issues, learn more about user base, or detect bottlenecks and dependencies. So it can also be performed automatically or semi-automatically. Data mining is more useful today due to the growth of big data and data warehousing. Data specialists who use data mining must have coding and programming language experience as well as statistical knowledge to clean, process, and interpret data. So, what data mining outputs goes into data analytics? Data analytics is the process of analyzing raw data to find trends and answer questions. It has a broad scope across the field. So, as discussed earlier, data mining tries to find answers to our questions using the big data we have stored. I have listed few examples of how data mining can be used. Number one is shopping market analysis. There's a huge amount of data in the shopping market, and the user needs to manage large data using different patterns. Market basket analysis is a modeling technique is used to do the analysis. Market basket analysis is a modeling technique based on a theory that if you buy a group of items, you are more likely to buy another group of things. So this technique may allow retailer to understand the purchase behavior or of a buyer. Number two is stock market analysis. There's a vast amount of data to be analyzed in the stock market, so data mining technique is used to model those data to the analysis and come up with even predictions such as movement of a stock price, see the trends over a longer time duration like 10 to 20 years, and then number three is weather forecasting analysis. Weather forecasting system uses an enormous amount of historical data for prediction. As there's the processing of enormous amount of data, one must have to use the suitable data mining technique. And then we have fraud detection. Due to the size of the data, the traditional methods of fraud detection are time consuming and complicated. So, data mining helps in providing meaningful patterns and turning data into information. Number five is intrusion detection. Data mining can help to improve intrusion detection by adding a level of focus to anomaly detection. So it supposed an analyst to distinguish activity from common everyday network activity. Number six is financial banking. A tremendous amount of data is supposed to be generated with new transactions in computerized banking. Data mining can donate to solving business problems in banking and finance by finding patterns, casualties, and correlations in business information. Number seven is surveillances. Video surveillance is used in a day-to-day life almost at every place for security perception. Data mining is used in video surveillance as we need to deal with a large amount of collected data. Number eight is online shopping. In online shopping, e-commerce companies like Amazon, Flipkart, Snapdeal, and many more uses data mining and business intelligence to offer cross sells and upsells through their websites. Number nine is bioinformatics. Data mining approaches are well suited for bioinformatics as it contains a massive amount of data. The mining of biological data is to extract useful knowledge from massive datasets gathered in biology and other related life sciences areas such as medicine and neuroscience. Number 10 is healthcare and insurance. The growth of the insurance industry entirely depends on the ability to convert data into knowledge, information, or intelligence about customers, competitors, and its market. So, data mining is applied in insurance industry. Big data possesses its own challenges and issues when it comes to implementing a good big data solution. First challenge is managing massive amounts of data. It's in the name, big data is big. Most companies are increasing the amount of data they collect daily. Eventually, the storage capacity a traditional data center can provide will be inadequate. To handle this challenge, companies are migrating their IT infrastructure to the cloud. Cloud storage solutions can scale dynamically as more storage is needed. So, big data software is designed to store large volumes of data that can be accessed and queried quickly. Secondly, integrating data from multiple sources is a challenge. The data itself presents another challenge to businesses. So there's a lot, but it is also diverse because it can come from a variety of different sources. A business could have analytics data from multiple websites, sharing data from social media, user information from CRM software, email data, like many more. So none of this data is structured the same but may have to be integrated and reconciled together necessary insights and create reports. Uh, Third is ensuring data quality. Analytics and machine learning processes that depend on the big data to run also depend on clean, accurate data to generate valid insights and predictions. So, if the data is corrupted or incomplete, the results may not be what you expect. But as the sources, types, and quantity of data increase, it can be hard to determine if the data has the quality you need for accurate insights. Fourth challenge is keeping data secure. Many companies handle data that is sensitive. If a business handles sensitive data, it will become a target of hackers. So, to protect this data from attack, businesses often hire cybersecurity professionals who keep up to date on security best practices and techniques to secure their systems. Whether you hire a consultant or keep it in house, you need to ensure that data is encrypted, so the data is uh, useless without an encryption key. Add identity and access authorization controls to all resources so only the intended users can access it. Fifth is selecting the right big data tools. Uh, when a business decides to start working with data, there's no shortage of tools to help them do it. At the same time, the wealth of options is also a challenge. Big data software comes in like many varieties and their capabilities often overlap. So, how do you make sure you are choosing the right big data tools? Often, the best option is to hire a consultant who can determine which tools will fit best with what your business wants to do with big data. The sixth challenge is scaling systems and cost efficiently. If you start building a big data solution without a well thought out plan, you can spend a lot of money storing and processing data that is either useless or not exactly what your business is. So, big data is big, but it doesn't mean you have to process all of your data. Seventh is lack of skilled data professionals. One of the big data problems that many companies run into is that their current staff have never worked with big data before, and this is not the type of skill set you build overnight. So, working with untrained personnel can result in dead ends, disruptions of workflow, and errors in processing. Last but not least is the organizational resistance. Another way people can be a challenge to a data project is when they resist change. The bigger an organization is, the more resistant it is to change. So leaders may not see the value in big data analytics and machine learning. So that brings us to the end of our lesson on big data. Hope you learned something useful because this is the future. If you have not subscribed to our channel, please subscribe so that you get notification when we upload new videos. So until next lesson, thank you and see you soon.